Welcome to aminacademy.com. In numerical methods and analysis, let us derive the normal equations for fitting of a straight line. Here, let y equal ax plus b is the equation of straight line fitted for the given data of suppose the data are let x1, y1, x2, y2, like x3, y3 up to now xn, yn. These are given data of the curve. These are the observations, n observations are there, which fit the line 1. Suppose which these points are fit in line 1. Let us assume y1, y2, y3 up to yn are the points or expected values are when we put these are expected value when we put the x values x are x1, x2, x3 up to xn in successively one. Suppose if you put the values of x as x1, x2, x3, x4 like in the equation y equal to ax plus b, we get the expected value of y. Now let us put this value. Suppose here y1 equal a x1 plus b, like y2 equal a x2 plus b, like that. We can give yn equal a xn plus b. Let the observed values of y be already y1, y2, y3 and yr corresponding to the value of x1, x2, x3 up to xr respectively. We can suppose y values are y1, y2, expected values of y are y3 up to, we'll keep yr, and for giving x values of x1, x2, x3 up to xr. Now the residual means small difference. The residual dr equal observed value minus expected value. Now therefore dr equal axr plus dr equal yr minus axr plus b. Now if we define a quantity E such that, suppose E equal sum of square of residuals, means d1 square, d2 square up to plus dr square. This is the sum of the squares of the residuals. Now we can write E as, suppose d1 is y1 minus ax1 plus b the square, because d1 square, like d2 square is y2 minus ax2 plus b the whole square, up to like here up to plus, then yn, because here n equal to r, equal yn minus axn plus b the whole square. Like we are adding all residuals, square of the residuals. According to the principle of the least squares, the constant or parameters a and b are so determined that the residual e should be minimum. Here e should be minimum to fit a car. Now partially derivative, finding the derivative of dE by dou E by with respect to dou A equal, if you differentiate the E function with respect to A partially, we can get 2 into y1 minus a x1 plus b into minus x1, because derivative of ax1 is minus, because with respect to a we are doing, therefore minus x1, like then plus 2 into same y2 minus ax2 plus b into minus x2, like it's goes plus 2 into yn minus axn plus b with minus of xn. Now for minimum we should use dou E by dou A equals 0. Regarding that, we will get, if we equate dou E by dou A equal to 0, we will get, after simplification, we get x1 y1 x2 y2, like it goes up to xn plus xn yn. This is the first set. Then xn yn, then minus a into x1 square plus x2 square up to plus xn square, and minus b into x1 plus x2 up to xn. We got this relation of equating dou E by dou A equal to 0. Therefore, in terms of now, in terms of sigma, we can write as sigma r equal 1 to r equal to n. You can write xr yr minus a into sigma xr square minus b into sigma r equal to 1 r equal to n sigma xr equal to 0. Therefore, you can write as sigma r equal to 1 to n xr yr equal a into sigma r equal to 1 r equal to n xr square plus b into sigma r equal to 1 n xn. So dropping of the suffixes, in generally we can write, without suffix we can write sigma xy equal a into sigma x square plus b into sigma x. So similarly, by partially derivating with respect to b, that is dou e by dou b, we can write the equation partially derivative is y1 minus ax1 minus b into minus 1, because with respect to b here, like if it is going like, then plus y2 plus y1 minus, then minus b1 plus 2 into 2 into for y2 minus ax2 minus b into minus 1, like it's go up to 2 yn minus axn minus b into minus 1, like we follow with the sigma notation, and dropping the sigma notation, finally we'll get so this is a sigma x plus n into b equal sigma y, finally get. Therefore we got two equations. We'll write in combined form here. A into sigma x plus nb equal sigma y is the first one. Second, a sigma x square plus b sigma x equal sigma xy. This is your least square equation for best fit. We have done. Please subscribe our YouTube channel.